Introduction to Inverse Functions. So what is an inverse function? Well, it's a function where we normally have an input for a function, which is usually x, and it outputs a value y. And an inverse function is actually going to switch these around. So we're normally given an input, we get an output. What happens if we put the output in and we want to get the input? So might make sense with an example. So if we have a function y equals 4x plus 8, let's just look at what happens when we have x equals 2 as our input. So we get y equals 4 times 2 plus 8, so we just get 8 plus 8, which is 16. So if our input was 2, our output was 16. But what if we wanted a function where when we inputted 16, we got an output of 2? And the way we go ahead and do that is we actually just swap the variables x and y around. So let's do that. So we're going to swap x and y. So wherever you see y, we're putting x, and wherever we see we put x, we put y. And then you just go ahead and make y the subject. So if we minus 8 from both sides, we'll just get 4y equals x minus 8, and then divide everything by 4. We'll get y equals a quarter x minus 2. And we can even check if this worked. What if this time our input was x equals 16? So we're going to get a quarter times 16 minus 2. So a quarter times 16 is 4 minus 2, which is 2. And we've successfully created a function now that reverses what happened with the original function. So we had an input of 2 and created an output of 16. Then we've created a function over here, which given an input of 16 creates an output of 2. And these two functions actually have a geometrical significance. So let's graph both of these and see what happens. So our original function of y equals 4x plus 8, we'll put this one in blue. So it has a y-intercept of 8 and an x-intercept of minus 2. And it's going to look something like this. Whereas our new function, our inverse function, has this equation here. So its y-intercept is minus 2. And its x-intercept, if you made y equal to 0, so you'd add 2, then times by 4, and you'd get 8 for the x-intercept. And what's happened is that y values have become x values and x values have become y values. And the geometrical significance is that these two functions are both symmetrical about the line y equals x. Now we're also going to talk about inverse function notation, and you've actually seen this before if you've done just some basic trigonometry. So when solving an equation like sine theta equals a half, you've been writing that theta equals sine minus 1 of a half. And this is actually just the inverse function of sine, because given an input for theta, we get an output of a half, and now we want to know what happens when we take that output and make it as the input. What is the output? So the notation for inverse function is actually this -1. So if we have some function, its inverse function is f of minus 1 of x. And it's not to be confused with It's not the same thing as 1 over f of x. These are not the same things. If you wanted to express this, you'd have to write it as f of x all to the power of minus 1. Let's have a look at just a couple of examples of sketching some functions, sketching some inverse functions given a function. So what if we had y equals x cubed? How would we sketch its inverse? Well, we can just think about the line y equals x. And all we have to do is reflect about that line. So using that line as a mirror, so this part would go over here, this part would go like that, this part reflected there, and that like that. So we're expecting some kind of shape like that for its inverse. What about just a simple y equals x squared? So again, let's draw in y equals x, because it's going to make it easier to sketch our inverse function. So, this part is going to do something like that. This part is going to go like that. And if we reflect this part here, it's going to do something like that. Now, just wanted to do this example to bring one more thing up. Just because we had a function to start with doesn't mean the inverse function is going to also be a function. So you can see our new inverse is actually a relation, not a function, because it does not pass the vertical line test as it makes two cuts. So sometimes when you take an inverse function, you have to restrict its domain or range, so you only end up with a function. So if you were to define this as a function, you would have to get rid of some of the function, as in maybe this bottom half or the top half.